I am going to be talking about opportunities in digital technology and the cost of that, which is primarily in the hardware and the data center. So opportunities have been outlined by various other speakers. Off the top of my head, I would say that data and data processing is good for smart manufacturing, which designs out waste. It's good for sharing economies, and it's good for predicting weather patterns, which would help with electricity. However, there is a cost on that, and that's what I want to talk to you about today. So this is me. I spend a lot of my time looking at circular economy, both within our company and also in the industry, and seeing how we can advance that in the data center sector. And the other thing that I do that's relevant here is that I chair the KTP with the University of East London that looks at the energy efficiency of servers. And that will be obvious why that's important later. So Techbuyer, as a company, buys, refurbishes and sells server storage and networking. And this is what we deal with a lot. And when you open up a server, you'll find a lot of materials in there. You'll find the precious metals, you'll find conflict minerals, critical raw materials, and they will be present in alloys and coatings, which means that recycling these materials is impossible to recover 100% of materials with current technology. When you flip over to the energy side, you find that servers are important because they account for about 75%, I think it is, of energy usage inside the data center. And the components that are responsible for that are the CPU, storage, and memory. Now, there's been a change in server refresh previously and today. So in times gone by, you get a significant energy efficiency increase if you refresh to new equipment. The orange line shows that at maximum usage, and the blue line shows that at low power mode. 5 years ago, refreshing to new brought you a lot of benefits. Now, the maximum energy usage seems to be tailing off a little bit. Sorry, maximum energy efficiency is tailing off a little bit. And at low power mode, we're actually seeing a decrease in energy efficiency. And that's important because servers spend about 70% of their time in low power mode in a real life situation. So the macro picture on this is that ICT is going to be responsible from somewhere between, I think, 8 and 20% of the world's energy usage going forward between now and 2030. E-waste is currently about 50 million tons globally a year. By 2050, reports say that's going to be 120 million tons per year. When you look at what that means on the server side and what it costs us to produce them, you see a lot of water, a lot of energy, critical raw materials, precious metals, a load of air emissions at manufacturing stage and at use stage, and potentially a lot of pollution. So what is the case for reusing equipment and therefore capitalising on that investment in energy and critical raw materials? Well, we ran a series of tests with the University of East London looking at new servers and the same make and model of refurbished server and various hybrid combinations in between. And we tested them according to industry standard metrics for compute power and energy draw. And the university researcher found that effectively there's no difference between refurbished equipment and new equipment. So then we asked another question, which is, if there's no difference between refurbished equipment and new components, what's the case for remanufacturing fully built machines using refurbished parts? How can we create efficiency and compute power gains while doing that? So we tested a standard configuration of the latest generation of server. And we compared that with the standard configuration of the immediate previous generation of server. And then we messed around with it. So we upgraded the CPU here. We doubled the RAM and kept the same CPU. We doubled the RAM and we upgraded the CPU. And you'll see 3 out of those 4 use cases, you actually get higher performance with a previous generation of server for less money, without wasting materials, and you won't have an efficiency loss. And that led us to understand what we'd read about what Google had been doing since 2015 at least. So they run their own in-house refurbishment program. They see no distinction between refurbished and new inventory for spares and upgrades on the component level. About a fifth of their new machines, I think, are remanufactured machines. A fifth of those deployed and remanufactured machines, and they're saving billions in the process. So if Google are doing that with their own hardware, and we're seeing a case for that happening with enterprise hardware, we're kind of wondering what's stopping that from being more widely adopted. So the barriers to change that we're seeing are partly technical. So component parts are incompatible between manufacturers, as you would expect, but also between generations. And that's kind of blocking a more circular approach to component level upgrade. Another thing that we're seeing is more on the attitude side. So procurement processes tend not to be specific for servers. They tend to be more broadly over ICT. First thing, some organizations will look at the accounting value of their equipment rather than the intrinsic value of their equipment. And also, sometimes people don't want to put themselves at risk because they feel that using refurbished product is going to come back on them in some way. We're also seeing manufacturer blocks in a way in terms of IP, which is kind of being derailed by the Eco-Design Directive, and also by limiting sale of equipment that's manufactured in one region into another region. There's a misconception that data destruction mandates hardware destruction, which means that we're getting a lot of waste where the materials in that waste are non-recoverable or not 100% recoverable with current recycling technologies. So if we look at what's happening now and what's stopping change now, we can then fast forward that to 2050. And there's a caveat to what we're seeing now. One is that we don't know what materials are going to look like in 2050. For one thing, quantum computing is possibly going to be more mainstream by then, which means a complete change out of materials. For another thing, with the move towards the edge, you're going to see networks become more important than servers, so the conversation needs to change there. However, we can begin to change the way that we think about things and our flexibility in terms of how we think about the value in equipment, how we think about designing our systems, and what presents best value. And if we start that process now, we should be in a good position to deal with changes as they come along. Okay, I'm going to stop my screen share here so that I can look at any questions that there are. And I can't see any in the chat box. And Q&A. Can engagement narrative around critical raw material resilience or embodied carbon open up more demand for remanufactured hardware? I think so, because when you talk about critical raw materials, you're talking about a massive risk and a massive challenge to development going forward. So these materials may well run out within 100 years. 2050 takes us much closer to that. And the other thing about starting the conversation is that we tend to, I think you'd probably see more value placed on what's inside the equipment rather than its monetary value, if that makes sense. Please tell me if that answered your question or not. Yeah, that's great. Thanks, Astrid. Okay. Sorry, I've kind of romped through that. Are there any more questions before we move on to Daniel?
You've got another one in the chat box from Robbie there.
Oh, sorry. How can we get this message across in terms that everyone can get it? The message about component level upgrades. I think that we need to start thinking about what data means and understanding that data is not free. That's the first step. Data, whenever you use it, whenever you take a picture, whenever you save that picture, whenever you transfer that picture to a cloud or share it with your family and they transfer it to a cloud, there's an assumption that that's somehow free, and it's not. It has a massive energy component to it. And there's been good work that's been carried out with Uptime quantifying that, looking at, for example, a post on Instagram by a famous footballer and how many homes that will generate energy for if you look how many times it's shared and how many times it's downloaded on some other machines. So I think the statistic is that every time he shares a post, that energy ripple effect is enough to heat 7 homes. I'm not sure how accurate that is, but if you put it in terms like that, then people start to understand what's happening. And they also understand that what happens with their phones has a knock-on effect through the networks and then has a knock-on effect in the data center. And I think we're kind of getting there if we talk about things in that way. Okay, I'm going to pass on to Mike Gent now. Thank you very much.
I just had one question about, so you said that the parts are incompatible between different like generations of devices or whatever, or between who's manufactured them. Does it need like legislation to standardise that, or is there opportunity for collaboration between businesses?
Ideally, you'd look at industry collaboration. One of the parallels that often drawn is between current IT hardware or data center hardware and the railways in the US. So when the railways first started, you had all these different companies making all these different tracks and none of them fit together. And when that was standardized, then you started having a rail network that actually worked. In an ideal world, you'd hope that manufacturers would come together and collaborate. But when I'm talking about procurement practices and accounting values and protectionism, I think that the way that our current business is set up kind of stops that from happening. So I guess government could try and do it. There are limits to how much legislation can help with this, I think, because there are sometimes technical reasons why you can't put a certain component on the motherboard of a different server. For CPUs, for example, it affects your memory and your storage and your surrounding infrastructure. So it's not just a case of changing the pins and putting one in. For other components like fans, I think that argument is a lot less valid. And if you had more understanding, which is part of the CIDASI project that we're trying to work on, if you had more understanding on what could be more compatible and what couldn't, and some studies done on those lines, then you would be able to inform legislators properly and have some decent legislation that works from a technical point of view. And then it's up to legislators how big a stick they want, if that makes sense. You know, how strong they want to be on this, and whether they feel it's going to stifle development in an area that kind of has to grow anyway because we're more and more reliant on digital technologies.
Cheers.
Okay.